The Cold War, a protracted geopolitical struggle, emerged in the aftermath of World War II. On one side, we had the United States and its allies. On the other side, the Soviet Union and its allies. Though it was labelled a Cold War due to the absence of direct military confrontation, it was anything but. It was characterised by intense competition, espionage, and proxy wars, all under the looming shadow of nuclear annihilation. This intense competition manifested most clearly in the skies, the space race. The spark of the space race can be traced back to October 4th, 1957, with the iconic launch of Sputnik 1 by the Soviet Union. The United States perceived Sputnik as a challenge to its technological and military dominance, igniting a fierce competition. The Cold War's geopolitical tensions and the development of intercontinental ballistic missiles were key factors driving the advancements in space technology. Notably, the United States responded by creating NASA and initiating the Apollo program. This program was instrumental in showcasing American space technology prowess. Neil Armstrong's first footsteps on the moon signaled to the rest of the world that the United States had indeed won this round. The Cold War era injected massive resources into space programs and STEM education, fostering leaps in technology. It was not just a race to the moon, but a race for global prestige, influence, and the admiration of people worldwide. The United States and the USSR were not the only two countries involved in space-related activities during the Cold War. From the 1960s, new countries started to be seriously interested in the space conquest. Astronomers in 5 European countries had, in 1962, launched a formal cooperation called the ESO, the European Southern Observatory. By 1974, it had 6 members. In 1964, space scientists taking CERN as a model requested the formation of ESRO, the European Space Research Organisation. In 1961, rocket scientists in Britain, Australia, and Europe encouraged their governments to create ELDO, the European Launcher Development Organisation. In 1974, ELDO and ESRO were united as the European Space Agency. An era of boundless exploration dawned in 1958 with the establishment of NASA. In the same year, the Space Science Board was brought into existence by the US National Academy of Sciences. The primary role of the SSB was to offer expert guidance to the nation and its agencies regarding the scientific aspects of NASA's ambitious programs. In 1973, the SSB expressed concern about the absence of a similar European space advisory body. European space scientists realized that a collaborative effort was needed in order to ensure that their voices were clearly heard on the other side of the Atlantic. The turning point occurred on the 10th and the 11th of April in 1974. A meeting between Friedman and Massey set the stage for a remarkable collaboration. A team composed of European planetary scientists, high-energy physicists, and 3 members of the US Space Science Board came together under the auspices of the Royal Society in London. This historic gathering marked the birth of the PSSAB, the European Provisional Space Science Advisory Board. The primary objective of the PSSAB was to establish a platform for European planetary scientists mirroring the SSB in the United States. They aimed to issue independent recommendations on space science programs and to provide Europe with a body akin to the SSB. The pioneering endeavours of the PSSAB set the stage for remarkable early activities. Firstly, in 1975, as the convention establishing the European Space Science Agency was taking shape, the PSSAB insisted that a scientific programme committee be included to manage the science programme within ESA, instead of being managed by the ESA Council as initially planned. The unanimous view of the PSSAB was conveyed to the Acting Director General and to the national delegates of ESA. As a result, the following statement was included in the Convention. The Council shall establish a Science Committee, to which it shall refer any matter regarding to the mandatory science programme. It shall authorise the Committee to take decisions on the programme, subject to the Council's function of approving the level of resources and the annual budget. The terms of reference of the Science Committee shall be determined by a 2/3 majority of all Member States and in accordance with this article. Around the same time, the PSSAB reached out to the newly born European Science Foundation. It officially joined the foundation as an ad hoc committee in 1975, transforming into the ESSC, or the Space Science Committee, with Professor Sir Harry Massey as its first chair. Together with the renowned SSB, the ESSC co-organised the International Discussion in Space Observatories Conference in the picturesque locale of Williamsburg, Virginia in 1976. This gathering achieved resounding success, generating profound insights and recommendations on a multitude of crucial topics. The beginning of the 80s saw the arrival of Roger Bonnet as head of science programme and the establishment of the ESA Horizon 2000 programme. ESA initiated a large consultation of the European community as to which missions should be included. SSC took a part in the working groups that were created to evaluate the 77 mission proposals received from the wider community. In 1982, responding to a request from the President of the USNAS and the ESF, the representatives of the SSC and the SSB came together to create a joint working group on cooperation in planetary exploration. This dynamic working group was tasked with exploring the feasibility of jointly planned and executed space missions to planets and primitive solar system bodies. Collaboratively with NASA and ESA, they aim to formulate a strategy including specific missions for such a program of collaboration. The joint working group reached several critical conclusions. They saw a solid foundation in programs like ESA's Giotto and NASA's Galileo. 3 missions were selected for collaboration, including the Titan probe and Saturn orbiter, the Multiple Asteroid Orbiter, and the Mars Surface Rover. Notably, the Saturn mission was launched on a partnership basis in 1997 as Cassini-Huygens. 2 years later, a crucial gathering happened at the Max Planck Institute. This workshop marked the culmination of years of dedicated effort and collaboration. This historical workshop, co-organised by the ESF and the NSF, brought together experts and visionaries. The workshop's recommendation was a pivotal moment in the history of space exploration. It paved the way for the Cassini-Huygens mission, a remarkable example of international collaboration. The Cassini mission stands as a flagship achievement, exemplifying what can be achieved when nations pool their resources and expertise for scientific advancement. The European Huygens lander remains on the surface of Saturn's moon Titan, and is, to this day, the farthest landing spacecraft ever made. ESA, guided in part by the foundational contributions of the ESSC, has orchestrated a series of influential space missions. Notable endeavours include the iconic Ariane launches, the deployment of the Hubble Space Telescope, and the groundbreaking Rosetta mission, culminating in the first soft landing on a comet with the Philae lander. The strategic influence of ESSC can also be traced in missions such as Planck, unravelling the mysteries of the cosmic microwave background radiation, and ongoing initiatives like Gaia, Copernicus, and Galileo, which collectively underscore Europe's pivotal role in advancing global space exploration and in creating the world's leading constellation of research and operational satellites for Earth observation and meteorology. In the early 90s, several structural changes occurred within the ESSC, notably the status of the committee within ESF. At the end of 1993, the new ESSC chair, François Becker, hired an executive secretary to support the ESSC, Jean-Claude Worms, who then led the space science unit created within ESF a few years later. Two new panels were created to take stock of recent entrants into the field: Earth observation and microgravity research. Around the same time, the ESSC started to invite, in addition to SSB representatives, international guests such as Russian, Eastern European and Japanese representatives, and national and European scientific body representatives. In November 1991, the ESSC started to formulate recommendations to the ESA Council of Ministers, and lobbied strongly to be represented in various advisory or decisional structures with an observer status. As a result, it was invited to participate ex officio to the scientific advisory committees of ESA and to be a member of the EU's Space Advisory Group. The end of the decade was highlighted by the first participation of the committee as an observer to the ESA Ministerial, representing the independent voice of the European scientific community. Since then, the presence of the ESSC has become the norm during the ESA Ministerials, and remains the only independent committee attending and being able to give a statement in front of the European ministers.
Can ensure that European space science and ESA flourish in their second half century as spectacularly as they have in the first. We have a supporting paper uplifting ESA science funding, which makes the arguments for funding science, and ESA space science in greater detail.
Beyond ESA, ESSC expanded its mission to facilitate the emergence and consolidation on the European scene of many scientific fields born out of the diversification of space domains, such as space weather, global monitoring for environment and security, or the study and monitoring of near-Earth objects. The European Space Science Committee stands as a cornerstone in shaping the European space landscape. As a defender of space science, the ESSC has played a pivotal role in steering the course of our collective exploration. From its founding, the ESSC has been instrumental in fostering scientific inquiry and ensuring a comprehensive understanding of our celestial surroundings. Today, its influence extends beyond the realm of discovery and into the strategic policies that drive our endeavours. Like a celestial compass, the ESSC continues to chart our course, reminding us that the pursuit of knowledge is a timeless voyage that transcends the boundaries of our world and extends into the unknown.